So I have simple bulb here, right? Lamp. So suppose if I connect it this way, so you can see it's very dim, right? Because the current flow is very low, because it's giving approximately say 1.4 volts or something, right? Can you see it, everyone? So suppose if I want to do something like this, so I'm going to connect it on this side. So now what happened? So what made the difference? So when you put the cells in series connection, right, the voltage is increasing, right? So when you put it in series connection, voltage increases, right? Because this 1.4 plus this 1.4, it becomes 2.8 or approximately 3 volts, right? So when the voltage increases, according to Ohm's law, you know, V is equal to IR. So current also increases, right? So that's what is happening here. So instead of one battery, so that's why most of your torch lights will have 2 or 3, right? So it will be like now increasing the voltage. Okay, so that is series connection. Let me try something like this. So on this side I have the both the positives, right? On this side I have the negatives. So let me just touch it like this, and then let me touch it like this. How many times did I tell you? Human body is capable of taking up to say easily up to 80-90 volts without any issues. Okay? So we are mostly working, you know, after this battery eliminator, we are working only with less than 12 volts. Okay, so 1.5 volts, nobody will get a shock. Okay, so don't worry too much about getting a shock. So when I connect it like this, when I touch it like this, right, let me try if this works. Okay, so it's not as bright as the earlier case, right? The series connection. So what do you think? What connection is this? Parallel, right? So when you put it in parallel, right? So basically it's same like having one battery. Why? What's going on here? When you put two batteries, you would expect it to be better, right? Voltage stays the same. Okay, very good. So in parallel connection, voltage stays the same. So does that mean there is no use at all putting another battery? Stays longer, very good. So even though the voltage is same, right? So if with one battery, if it was going to run for 1 hour, right? With two batteries, it's going to run for 2 hours. So it's not like it's completely no use, right? So as far as the time goes, there is some advantage. Are you following that? So that means you should understand that series connection means voltage gets added, right? Parallel connection means it stays the same, right? What if I put it like this instead of putting it like this, right? So this is plus goes to the minus, right? So that means this we call it as series connection, right? So what if I put it like this? Won't work? Okay, let's double check that. So I can't see anything, so I think you are right, right? But what if I put one more like this? Can you hold this also? Should I come here? So now what's happening? I have 3 batteries. 2 of them are opposite. The other one is like, you know. So what do you think is happening?
You take the center battery, it still works.
If you take the center battery, okay, remove that. It's not going to work, right? Without the center battery, it's not going to work. So what's going on here is, just hold this one more time. So let me show you here voltage. So when you put one battery, right, like this, it's somewhere around 1 point, what is that? 1.37. So let's take it as 1.4. So this is 1.4. Want one more? look at this one. This is 1.6. Okay, that is 1.4. This is 1.6, right? So if I put it like this, 1.4 plus 1.6, that will be 3. Okay, hold this. Let's double check if we are getting that. Did you change the batteries? Okay, show me correctly.
Yes, sir.
2.973, right? So that means it is getting added up, right? So now, as I said, I'm just going to change this one. So instead of connecting the plus to the minus, which is a series connection, right? I'm going to put it like this. So hold it like this. So what do you think is going to happen now? Nothing is going to happen.
Go negative.
Go negative. Okay, let's check that out.
Minus
0.2.
0.245.
So where did that 0.2 come from? Remember, one was 1.6, the other one was 1.4, right? So whichever is bigger, that way the current is going. So it's like saying an easy way to understand this is, let's say I applied 2 Newton this way, 2 Newton this way. That means the object is going to be stationary, right? But if I apply 5 Newton this way, 2 Newton this way, then 3 Newton this way, resultant is this way. So that's what is happening in a battery. So when you put plus, it's trying to push the charge on one direction, right? So this is trying to push it with 1.4 volt, but this is trying to push it with 1.6 volt. So 1.4 minus 1.6, so 0.2 will be the resultant voltage. Are you following that? Okay. So very often you will get this kind of concepts in your numericals. So they will give you one battery on this side. Okay, thanks. You may have to come back again. So if I say this is 1.4 volt, right? If I give it like this, plus is connected to the minus, which means from here to here, if I measure it, what did I see? 3 volt, right? So if I connect it like this, so you will get this in the numericals, so make sure you are understanding this properly. So this is 1.4 volt, 1.6 volt. So this will cancel each other. So that means it will be 0.2 volts this way. So 0.2 volts. Okay. Opposing each other's direction. This is series. But suppose if I had something like this is say 1.4 volt and this is 1.6 volt. Okay. And if I check the voltage across this 1.5, I don't think it will be that simple. Okay, let's try that. Forgot to check that. So yeah, sure. So this is 1.6 and this is 1.4, I believe, right? So let's put it like this. So I'm just going to put it across this and this. Okay, this is going to be slightly difficult. I need a proper system to do this. So this is connected with this. So these pluses are connected together, right? And then let's say for the minus you may have to hold it because I don't have a protrusion there. So hold it like this. Hold this. So what's the voltage there? 1.5. Okay. That means Yash was correct, right? Somewhere in the average. So you can see it doesn't matter where. So wherever I put that, right? Can you just hold it here? So if I check it across this battery, or if I check it across this and this, I'll get the same values, right? Is that correct? So take it down. This will be 1.5 volt. Yeah, thanks. So this is for your understanding, okay? For your examination purpose, the way it works is series connection means you have to do series of cells. So let's say I have something like this, internal resistance. Right. So this is, I'm going to call it as EMF1, EMF2, R1, R2, and voltage across this is going to be V1, voltage across this is going to be V2. So if I want the total voltage, V total, it will be this plus this. So V1 is nothing but terminal voltage. So what can you say about the terminal voltage in terms of E and IR? If the current flowing is I, can you tell this in terms of this? E1 minus I R1 plus E2 minus I R2. So this and this I can bring it together, minus I R1 plus R2. Very often we do the concept of equivalent resistance, equivalent capacitance, equivalent something, right? So what we are trying to do here is, so suppose if I put V total here, so I am going to say the equivalent EMF will be E equivalent here minus I R equivalent. So for series connection, the equivalent EMF is E1 plus E2, R equivalent is R1 plus R2. So it's very straightforward. So E equivalent is equal to E1 plus E2, R equivalent is equal to R1 plus R2. That's all. So as far as series connection goes, that's all. Any doubts here? A series connection, so we are adding the voltages and replacing it with this formula, and then we are saying this looks like a complete for the entire circuit, right? What can I say? This is E equivalent minus I R equivalent. So this is E equivalent, this is R equivalent. That's all. Just comparing it. Then we need to do the same thing in the case of parallel connection. Can I erase this? Anybody still copying this? Copying? Okay. Can I erase this? So now we need to talk about the parallel connection. So parallel connection of cells. So do the drawing very similar to this. Generally try to draw this very small so that it's internal resistance. Don't try to draw very big. So this is E1, R1, E2, R2, right? So the voltage across this is going to be the same, whereas the current is going to be different. So suppose if I had a battery here, this is a battery, right? Battery. Okay, so this is voltage. So the current from here, let's say this is I1, from here it is I2. So this is I1, this is I2, both are going to come through this pipe here, right? It's like 2 liters of water flowing here, 3 liters of water flowing here. So coming together, so it will join together to make 5 liters, 2 plus 3. So that means this is going to be the total I. Okay. So there the voltage you are adding for the same current, whereas here voltage is same. That's what we saw here. And the current is getting added up. So it will be I is equal to I1 plus I2. So just like what we did here, right? I need to write this I in terms of using this equation. So I can say, I can take it on this side. So E minus V divided by R is equal to I. Do you agree with that? This will go on this side, this will come here, R will come here and divide. You don't agree with this? So that means I'm going to say this is E minus V divided by R1 plus E2 minus V divided by R2. Why not V1 and V2? V is same, so you don't put V1, V2. So then you do, I can add this and this separately. So E1 by R1, E2 by R2 minus V can be taken out separately. I will get 1 by R1 plus 1 by R2. See if you agree with this. So we are going to do the same thing. So somehow we have to adjust it to get the E equivalent and I equivalent. So let's see, I is equal to 1. So I want to get the V, right? So V should be, so I want to make V as the subject of the formula or the equation. So that means I can say bring it on this side. So V 1 by R1 plus 1 by R2 is equal to this same term. This comes on this side, so minus I, right? So make a note here. So make V as the subject of the equation. I hope you are aware of this in from your maths, right? What do you mean by subject of the equation? You make that particular term as that equal to something, right? So that means I want to make V as a subject. So that means I need to bring all these things on the bottom. So I will say V is equal to E1 by R1, E2 by R2. I am going to bring this entire block below this. So that means I have to divide this and this, right? Because I will be bringing it here, but that is for this and this separately. So I am skipping some steps so that you can quickly understand the concept. So if you have trouble, let me know. So now I have made V as the subject of the equation. So now I am going to write similar to what I did there. So I am going to say V is equal to E equivalent minus I R equivalent. So in place of E equivalent, what do I have? I have this. In place of R equivalent, I have 1 by this. Right? So don't forget it is 1 by this term. So based on that, find out the E equivalent and R equivalent. So here we compared this and said this is equal to this is equal to this. So similarly, I have to equate this and simplify this. That's all. It's very simple. R2 plus E2 R1 divided by R1 R2 LCM, right? Divided by R1 plus R2 divided by R1 R2. So R1 R2 cancels. So I get E1 R2 plus E2 R1 divided by R1 plus R2. So in the example we did in this 1.6 and 1.4, the parallel connection, what is the answer we got? E equivalent 1.6 and 1.4 separately. In parallel connection, what did we get? 1.5. So how can I explain that? This is 1.6, this is 1.4, right? Because the individual things. Assuming, I didn't calculate the internal resistance, but if I assume that both are same, right? So I will get a R here, I will get a R here, this R plus R will become 2R. So if I take the R commonly out, R cancels. So this plus this divided by 2. So 1.6 plus 1.4 divided by 2. So make a note from what you did. So 1.6 plus 1.4 divided by 2. So that's why you got 1.5. So in that practical thing which you did, just go back and write this, assuming the same internal resistance. Similarly, I need to calculate the R equivalent. So R equivalent is equal to, what is R equivalent? 1 by R1 plus 1 by R2. Is that right? Is this correct? Just checking if anyone is awake still. See, Aditya is awake, right? All others are sleeping. So it's 1 by this entire thing is your R equivalent, right? So in place of R equivalent, you have this. So you are supposed to put like this. So that means it will be R1 plus R2 in the bottom, and then R1, R2 goes on the top. So R1, R2 divided by R1 plus R2. So that's your R equivalent. Okay. So if you see, series connection is much simpler, parallel connection is slightly. It's not complicated, but you need to remember what are the steps you are doing. Okay. Is that clear? Any doubts? So that's your 16th question, right? So 15th question we derived, 15th we finished here, 16th is what we did here, right? Explain Kirchhoff's law. So any doubts before we move on? Anything? Ajay, are you following? Without our knowledge, right, we have been using this. Why do you think I should say I is equal to I1 plus I2? If I send 2 liters of water and 3 liters of water, why should it be 5 liters? Why can't it be like 6 liters? Law of conservation of mass, right? So you cannot just like that create mass. So if you send 2 plus 3, it has to be 5, right? So it's the same thing here. Instead of water, what is it? Current flow. What is current flow? Flow of charges. So that means it's called law of conservation of charges. So based on law of conservation of charge is what Kirchhoff's law is based on. Energy is associated more with voltage or current? Voltage. Why? Voltage is joule per coulomb. Okay, one thing I forgot to tell you is here, right? So again, as always, you can think of the water analogy. Any idea how to make this as water analogy? Series connection, parallel connection. Again, it's not required for exam, only for your thinking.
Like waterfalls, waterfalls like parallel connection. The fall from the higher to the lower. But a parallel connection, series connection goes the same.
Okay. So in series connection, it's something like you have one level here, right? And then on top of that, you are adding some more level. So what happens to the pressure at this point? Pressure increases, which means the current flow will be more. Right? That is what is happening in a series connection. What about this one? So suppose in this one, if I showed you 2 tanks like this. So initially this is one tank, right? And then I am connecting one more tank like this. So will the pressure increase here? No, the pressure remains same. But instead of flowing the water for 1 hour, it will flow for 2 hours. Right? So it's the same concept here. So you can think of something like this. Right? Junction rule or current rule. Current law. So another name for this is junction rule. So if I take a point, right, and if I say there are a lot of points coming here, so let's say this is going out like this,